Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to start talking about graphing quadratic functions. We're going to learn everything about quadratic functions. We're going to know how to graph them. Then we're going to know how to solve by graphing. We're going to learn how to solve by what's called the zero product property, which we already talked about. That's with factoring. We're going to learn how to solve by completing the square. We're going to learn how to solve by using quadratic formula or the square root method. A lot of ways to solve. Real quick before I do any of this, just remember, guys, do you remember when we were factoring? And let's say I had x squared plus, let's say, 5x, and then let's just say plus 6. Okay? That's a quadratic function. All right? And if you guys remember, we factor. Well, times what is 6, but when added together is 5, and that's going to be plus 2 and positive 3. Then you remember the zero product property? You have to set this equal to 0 and this equal to 0. So x would equal negative 2 and negative 3, right? Does everyone at least vaguely remember that at least? Hopefully the factoring was real easy. The zero product property, remember, when you have a times b equals 0, both a and or b can equal 0, so you must set the factors equal to 0. Okay? Now, this is all fine and good and dandy, but when we did this a while back, I said there's a point to this. There's a reason to this. Does anyone remember what this negative 2 and this negative 3 represent? Yes, sir.
The plots on the line, on the graph.
Yes, those points, but those points are called someone said it? The x-intercepts. Guys, basically what happened here is my solutions were negative 2 and negative 3. So negative 2, negative 3. We're going to learn how I know this in a second, but this is an upward facing parabola. So what this means, my brothers, is that these are the solutions of that particular quadratic function. When you solve, you're finding what's called the x-intercepts. These guys right here. These are the x-intercepts. They're also called the solutions. They're also known as the roots. They're also known as the zeros. Anytime they tell you any of those words in a word problem, that's what they're looking for. That's what they're referring to. Does that make sense, guys? Okay, promise? So that's why we learned how to factor. That's why we learned the zero product property. Now today, I'm going to show you guys exactly how to graph this, and hopefully we'll start putting things together. So I just wanted to mention that because math is something that builds, and I wanted to make sure that you guys understand that we have seen half of this puzzle already. So I don't want you to be scared. Just focus. A quadratic function is ax squared plus bx plus c, or f of x equals ax squared plus bx plus c, where a and x cannot equal 0. Can anyone tell me logically what they think? Why could a not be 0 here? If a is 0, what occurs? Yes, sir, my brother. It'd be a straight line, correct. If this was 0 here, guys, that's gone, right? That's bye-bye. What am I left with? Bx plus c, x has a degree of 1. This would turn into excellent job. Excellent job. That'd be linear. So that's why a cannot be 0. Same thing happens, brothers, if x is 0, though, right? This guy will cancel, this guy will cancel, and you're left with y equals c. Remember a y equals c equation. It is a function, but it's very good. It's a horizontal line, and it goes to that c value on the y-axis. That's not linear, really, technically. That's called a constant function. But that's why a and x cannot be 0. However, if a and x are any number but 0, and you have x squared, what happens is you have a quadratic function. And a quadratic function produces a U-shaped graph. And this U-shaped graph is called a parabola, or they're called parabolas. Okay? This is what happens here. Now, The a and the b are coefficients, and the c is the y-intercept. So right off the bat, the number that's by itself, the c is y-intercept. How come? Well, the y-intercept is the y value on the y-axis when x is 0. If x is 0, that goes bye-bye, that goes bye-bye. I'm only left with c. So my y-intercept is the c value. Now, there are a few ways to graph. I'm going to show you one way today. But then there's going to be another method. And it's easier and at the same time a little bit more complicated. So let's really learn the vocabulary today. Let's really learn every intricate piece of this parabola. And then I promise you when I go to the next section, it's going to be a lot easier. I give you my word. Okay, guys, let's talk about this a, all right? Because we have y equals ax squared plus bx plus c. The a is very important. If a is greater than 0 and it's positive, that means that the graph points upward, just as you see here, gentlemen, the graph is pointing upwards. Okay? If a is less than 0, a is a negative number, then that means, gentlemen, the graph is pointing downward. It doesn't change, it doesn't oscillate, it doesn't depend on this, that, or the other. If a is greater than 0, straight up, it's positive, it points up. So that means if you're graphing a quadratic equation that has a positive a, and you mistakenly see that your graph is pointing downwards, stop, erase, do over. It's wrong. If your a is positive, it has to point upwards. Like vice versa. If your a is negative and you graph it and it's pointing upwards, stop, erase, you did it wrong, redo it. Okay, guys? If the a is positive, the graph points upward. If the a is negative, the graph points downwards. Okay, the c, once again, that's the y-intercept, the y value on the y-axis when x is 0. Now, parabolas are what's called symmetrical. You guys remember when you were kids? I'm sure everyone did this for either Valentine's or for Mother's Day. You drew half a heart on a folded paper. Yeah. You guys remember that, right? Or a folded shape of anything you wanted. And then you cut. And then when you unfolded it, it made it, not only did it make one whole heart, but it made it perfectly symmetrical. It was exactly even. This guy was exactly even to that guy, right? And then when they folded over, every point of one side of the heart touched every point of the other side of the heart. They were identical on both sides. That's what symmetrical means, guys. When you can cut something in perfect half, and when you fold it over each other, every point lines up with each other, that's called symmetry. That's symmetrical, okay? Does that make sense conceptually? All right. Well, parabolas are symmetrical, guys. And the line that cuts the parabola into perfect symmetrical halves is called the axis of symmetry, which is an invisible vertical line. It is not technically part of the graph. We're going to use it in every graph we ever do, because I'm going to show you it's a real easy way to get extra points. Not extra points for the test grade, but extra ordered pairs for your graph, okay? And it's an invisible vertical line, and it's found by using the formula x equals negative b over 2a. So that b, which is the coefficient of x, that's what we're going to use, that's the b. And the a, which is the coefficient of x squared, that's the a, and we're going to use that as well. It's an x equals equation because it's a vertical line. Although it's an invisible line, okay, it's imaginary, it doesn't really exist as far as the graph goes for real. It is a vertical line nonetheless, so it's an x equals equation. And as you can see here, I have two quadratic functions, one of them positive. This red dash right here, that's my axis of symmetry, okay? And over here, this is my axis of symmetry as well here in red. Notice that the axis of symmetry goes through this point here that's called the vertex. The vertex is very important. The vertex is here on the graph that's green, that's going upwards, and here on the graph that's blue, it's going downwards. The vertex, I kind of call it like the swivel point. That's where you get to your highest point, and then you start going down again, or to your lowest point, and then you start going up again. All right? We're going to talk about the vertex now in a second, but I want you to be able to envision what the vertex is. In this case, the vertex is at the maximum height or the minimum height? That's the maximum height. So the vertex, when the A is negative, is a maximum. The vertex, when the A is positive, is that a max height or a min height? That's a minimum. Very good. You had a question. Thank you for your patience.
It's like, if you know the vertex, don't you know the axis of symmetry?
I'm so proud of you right now. If you know the vertex, you know the X part of the axis of symmetry. Heck to the yeah. Good job, kid. Well done. And that's exactly what I'm going to show you right now. Well done. It feels good to know things, doesn't it? Proud of you, my brother. You remembered that from last year?
Yeah.
I'm very proud of you, kid. All right. So, does everyone understand the axis of symmetry and how you get it? It's a formula. X equals negative b over 2a. Now, the vertex, which we already saw, of a parabola determines the maximum or the minimum of the function. And it is found by using the following formula. This goes back to what my boy just finished asking and saying. He said, hey, Morrow, the axis of symmetry, that's x equals negative b over 2a. So he said, wait. Isn't this negative b over 2a also the x value of the vertex? You're darn right it is. In fact, once you find the axis of symmetry, you plug in the negative b over 2a value into the function to find your y. That's why the vertex is negative b over 2a, comma, f of negative b over 2a. Uh-oh, what the heck does he mean? Well, remember, guys, it's f of x. But what is the x in this case? Negative b over 2a. So what this means is simply plug in the value of the axis of symmetry into the quadratic function and solve for your y, which is also known as f of x. So once you have your axis of symmetry, you plug it into the function and you find your y value. That's going to give you your vertex, which is your maximum or your minimum. Are you guys with me so far? Promise? May I continue? No? Thank you, my brother. Okay. So now, guys, I put a couple graphs here, and I just want to show you, start showing you how pieces come together. Remember, please, if A is greater than 0, if it's pointing upwards, you have what's called a minimum. If A is less than 0, it's pointing downwards, you have a maximum, okay? Now, as far as this goes, I need you to make notes on this. I need you to understand what's going on. My y-intercept is right here because it's the y value on the y-axis when x is 0. My x-intercepts, these are the solutions, or the zeros, or the roots. My axis of symmetry goes right through the vertex, and this is my vertex, which happens to be a minimum. Now, the vertex is going to be an ordered pair, x and y. Please pay attention to this. And a lot of questions, especially the SAT, higher level order thinking, they're going to say to you, find and interpret the maximum values of this quadratic function. Or they'll give you a quadratic function and say, at what x value does the maximum occur? Or if they're talking about time as far as a moving object, they'll say, after how many seconds does the ball reach its highest point? All I asked were just interpretations of the vertex. And the vertex is a max or a min. So when you have a minimum or a maximum, it doesn't matter. When you have a vertex, guys, the minimum or maximum value, pay attention, equals the y of the vertex. and it occurs at the x of the vertex. So just for giggles, let's say that this vertex right here, just for giggles, was 10, negative 8. In this particular case, my minimum value, the value, would equal negative 8. Where does it occur? It occurs at x equals 10. The y value of the vertex is the value of the vertex. The x value of the vertex is where it occurs. The y value of the vertex is the value of the vertex. The x value of the vertex is where it occurs. Same thing over here, gentlemen. For the maximum, it's still a vertex. In this case, notice it doesn't hit the x-axis at all, so there's no x-intercept. There's no solution for this. No real solution. There's imaginary solutions, and we'll talk about that later. But for this particular case, let's say that this was the graph of a ball that's moving. You know, you threw it up and it's coming down because gravity, everything must come down. Anything that goes up must come down is the way it says. Anyways, let's say that this guy right here represents after, well, not after, 8.5 seconds, comma, let's just say whatever, I'm just making things up, 85 feet, okay? I can interpret this maximum very easily. This maximum states to me after 8.5 seconds, comma, the ball reaches a maximum height of 85 feet. So my max value would be 85 feet. Where does it occur? Thank you, my brother. It occurs at x equals 8.5 seconds. Guys, this is like the most important part of this. Forget about graphing it. Any graphing calculator can graph it for you. Whoop-de-doo. Interpreting it. That's the key here. So before I move on, because everyone understand how to read and how to interpret, and at this point how to find with formulas the vertex and the axis of symmetry, and do you know what they mean? Do you know how to interpret the value? Do you know how to interpret where it occurs? Sir, my brother, thank you.
Are there any other words that they would ask you about the max value of the curves, or is it just going to be like?
You know, I mean, that's a great question, son. The question was, are there any other words that they can use to ask you about the vertex and the where it occurs? Yes, they can ask you in different ways. That's why you really need to understand this. How many different ways? I don't know. I know that sounds like an ignorant answer. I don't know, though. They could say, you know, they could say things like, when does the maximum occur? If they're talking about time. At what x value does the minimum value occur? What is the minimum value when x is this? A lot of different ways, but if you could understand that the vertex is the max or a min, and the value of that max or min is the y or ordered pair, the y point, and where it occurs is the x, you will gain fluency. Sorry, it doesn't really answer your question, but thank you, my brother. May I continue, my brothers, or are there any other questions? Now's the time. Yes, sir. Continue? Yes, sir. Okay, now, another, you know me, guys, I like to repeat things, I know. It's not because I don't think you can handle it. It's the exact opposite. I want to make sure that I'm doing the best job that I can. So again, what is the graph of the quadratic function? Well, you have y equals ax squared plus bx plus c. That is a plus c. It's just not a good spot. Also known as a parabola. What does it look like? Well, the significant parts of it, what are they? Well, it's a U-shaped graph, okay? It's going to go through a y-intercept, and that's The y-intercept right there. Remember that that's the y value when x equals 0, or it's just the c value of the function. Either way you want to do it. The axis of symmetry here in green, it cuts the parabola in perfect half. And I find my axis of symmetry because it's a formula x equals negative b over 2a. My vertex is my max or my min, depending on whether or not the graph points upwards or downwards. And it also has a formula. It's the value of the axis of symmetry, the negative b over 2a. Then you take that value of the axis of symmetry, that negative b over 2a, that's the x value of the vertex. You plug that into the function, and then you find your f of negative b of 2a over 2a, which is f of x. In this case, x is negative b over 2a. Then I find my value. And then the last thing, I don't know why I forgot this. It was pretty silly, but we'll just reiterate it right now. This right here, these are my solutions. Those are my solutions, guys. At this point right now, they're going to be estimates for you because we still have limited solving capabilities. We know how to solve by factoring, but we still got to go over. We did radicals though, correct? We did our radicals chapter already, right? No, we've done rationals. Yeah. So I got to teach you how to do the square root method, the quadratic formula, and completing the square. Right now, all you can do to find these zeros right now at this point is graph this and estimate it, or if you're lucky and the original function is factorable, you can go ahead and factor it and use the zero product property. But for right now, we're just graphing, we're not solving. Does that make sense? Yes, sir, my brother.
Without the zero property, then we'd have to know the radicals.
Correct. I'm gonna learn. I'm gonna learn you all good. All right, don't even worry about it. May I continue, my brothers? Now let's put this together and let's graph a function, right? Let's graph one. Let's just do it. Okay, so how to graph. Now that we went through detailed everything, guys, this should be just fluid. But as always, I got steps. Follow the steps. So number one, find the axis of symmetry. Well, x equals negative b over 2a. Negative times negative 8 is 8 over 2 times 2, which is 4. So that's 2. So x equals 2. That's my axis of symmetry. So what am I going to do? I'm going to graph my axis of symmetry, and I'm going to graph a dashed invisible line going through x equals 2. Now that x equals 2, I'm going to find my vertex. My vertex is my axis of symmetry value, which is the negative b over 2a, which I already found to be 2. And then the y value when I plug that x value into the function. All of these skills we've done before. So this is 2 times 2 squared minus 8 times 2 plus 9. 2 squared is 4. 4 times 2 is 8. 8 minus 16 plus 9. 8 minus 16 is negative 8. Negative 8 plus 9 is 1. So my vertex is 2, 1, which is right there, and I go ahead and label that as well. Step 3, my y-intercept. My y-intercept is the c value here. So what's my y-intercept here in this case? 0, 9. Very good. So that's right here. Now, do you guys remember the axis of symmetry, how it's symmetrical? Guys?
Yeah.
That means that it cuts it in perfect halves, correct? That means if you fold it over, every point will match itself, correct? Check this out, guys. Here's the magic. Isn't this y-intercept 2 places to the left of the axis of symmetry? So now go 1, 2 to the right. Guess what, gentlemen? You've graphed a perfect parabola. Does that make sense, gentlemen? Now, we're done here. However, sometimes they want more points, or sometimes both the vertex and the y-intercept are the same value. If the vertex and the y-intercept are the same value, then you have to do one of two things, guys. You do the extra point and its mirror image, and I'll show you what that means. Or you find the x-intercepts, the roots, the zeros, which is more accurate by either, 1, locating it or them on the graph if they're perfect and pretty and You can see them perfectly. Or 2, solving for x using square root method. We're going to learn it. Factoring, you already did it. Completing the square, we're going to learn it. And quadratic formula, we're going to learn it. Okay? Now, in this particular case, this is not factorable. So what I'm going to do is I'm going to use an extra point. What does that mean, Morrow? Well, just do 1 point. What value of x do you want to use? Okay, let's do something easy, like when it's 1. When x is 1, I got 2 minus 8. 2 minus 8 is negative 6. Negative 6 plus 9 is 3. Now check out the beauty of the axis of symmetry. This is 1, 3, right? That's 1 to the left, so go 1 to the right. And now it's even more accurate. So the key here is knowing and understanding how to find the axis, the vertex, the y-intercept, and knowing how to work with that mirror image. Does that make sense, gentlemen, before we do another example? Everyone understands. Please do not be ashamed to ask, please. Oh, yes, sir? Okay, thank you. Okay, let's graph this. First thing you want to do always, though, guys, is write it in standard form. So f of x equals x squared plus 8x plus 9. My axis of symmetry. My axis of symmetry equals negative b over 2a. So this is negative 8 over 2 times 1. So it's negative 4. So x equals negative 4. I'm going to go ahead and graph it immediately. 1, 2, 3, negative 4. Bam. Now I want to find my vertex. My vertex is my axis of symmetry x, which is negative 4. Now I got to plug it in and solve for y. So negative 4 squared plus 8 times negative 4 plus 9. That's 16 minus 32 plus 9. That's negative 16 plus 9. That's negative 7. So negative 4, negative 7 is my vertex. So I go ahead and graph it. 1, 2, 3, 4, 5, 6, 7. Remember that your vertex has to be on your axis of symmetry. If it's not, you messed up. Y-intercept. The y-intercept in this case is c value, so that's 0, 9. Or you can literally just plug in 0 for the x, and you'll see that when x is 0, y equals 9 as well. Either way, 0, 9 is here. Now, I'm going to erase this. This is 1, 2, 3, 4 to the right. So what's its mirror image? 1, 2, 3, 4 to the left of its axis of symmetry. Now, we graph. What are my solutions? Well, if you notice, that's going to have to be an estimate, and that's going to have to be an estimate. This is real close to negative 2, so I would say that this one is about 1.8, negative 1.8. If they ask you for the solutions, you already have them. Is that an exact solution, guys? No, I'm estimating. We're not going to have an exact solution until I teach the quadratic formula. What about over here, this solution? Well, this is negative 1, 2, 3, 4, 5, 6 and a little bit. So I'd say this is about negative, roughly, about negative 6.3. Are those answers exact? No. Will those answers get you the right answer on the test or quiz? Yes. When are we going to learn the exact answers? When we learn the quadratic formula. Did I need an extra point for this particular case? No. Why didn't you need an extra point, Mr. Morrow? Because the vertex and the y-intercept were different values. You need an extra point when the vertex and the y-intercept are the same value. Again, I'm repeating it, and I don't see many people writing it, but you need an extra point when the vertex and the y-intercept are equal values. When the vertex equals the y-intercept, you need extra values. Does that make sense? And you just need to pick one extra value and then graph its mirror image. Now, How do we apply this? This is SAT right here. This is SAT. Okay? Thank you, my brother. First of all, it says determine whether the function has a max or a min. Well, which way is this pointing? Up or down? So does it have a max or a min? Right, it has a minimum. Guys, you may think that's really easy, but if you don't know, you don't know. It is easy. But that's because we just went over it. We learned it. Now, state the maximum or minimum value of the function. What are they asking me for? The vertex. Thank you. Yes, that makes me happy. How do we find the vertex? I first need the x value. How do I find the x value? Axis of symmetry. Negative b over 2a. So x equals negative b, which is positive 4 over 2 times 1. So x equals 2. That's my axis of symmetry. My vertex is the x of my axis of symmetry, which is 2, comma, the y value when you plug it in. 2 squared is 4. 4 minus 8 is negative 4. Negative 4 plus 9 is 5. So what is my max or minimum value here? In this case, it's a minimum. So what's my minimum value? What is my minimum value? My minimum value, guys, remember, equals the y value of the vertex. So my minimum value is 5. If I asked you, where does the minimum value occur? Exactly, okay? So the minimum value is 5 because it's the y value of the vertex. But it occurs at x equals 2. Does that make sense, boys? I'm going to give you one more because we have time. But I want to make sure before we do it that you got this, you understand this. This makes sense. Promise? Okay. Let's graph this one then, y'all. Let me get my graph paper here. Okay, let's graph this one, y'all. Y equals, let's say it's 2x squared. Let's do minus 6x. Let's do plus 5. Let's do that. Okay. Hey, I want you to graph this. Step 1, I need my axis of symmetry. My axis of symmetry is x equals negative b over 2a. Okay. So x equals 3 halves. Moro, what are you doing to us? You know I got to throw in a fraction. Because if not, when you see the fraction on the homework or something, you're going to get stressed. I don't want you to stress. So 3 halves is what, guys? It's 1.5. 1.5. So 1.5, my axis of symmetry is right here. How do you know that's exactly at 1.5? I don't. It's an estimate. So how will you know if we're right on our graph? Because you're going to show me work, and I'm going to see that you saw that the axis of symmetry was 3 halves, 1 and 1 half. I'm going to see your graph. If your graph is in between 1 and 2, doesn't that show me that you do understand? Right? Now, if you put your axis of symmetry at 7, no, then that you don't understand what you're doing. So I need the numbers, and then your graph may have a little tiny estimate here or there. Step 2, in my vertex. Don't stress, guys. My vertex, I use the x value for my axis of symmetry, and now I plug it in. So I got 2 times 3 halves squared minus 6 times 3 halves plus 5. This is 2 over 1 times 9 fourths minus, that's 18 divided by 2, so that's just minus 9 plus 5. So this is 9 halves. Negative 9 plus 5 is negative 4. Common denominator is 2, so this goes to 2, this goes to 8. So that equals positive 1 half. So my vertex is 3 halves, comma, 1 half. So I'm going to graph my vertex, which is about right here. Is that exact? No, but I know that it is exact because you gave me the exact value there. I had to graph an estimate. Now my y-intercept, what's my y-intercept here? That should be Mickey Mouse is step 3. Guys, we should just look at this. Thank you. It's 0, 5. It's the y value when x is 0, or the c value. So it's 1, 2, 3, 4, 5. Now, isn't that 1.5 to the left of the axis of symmetry? So its mirror image must be 1.5 to the right. And in this particular case, we go like this, and that's it. And guess what, guys? Does it touch the x-axis at all? So there are no solutions. Very good. So no solution. If it doesn't hit the x-axis, it's not a solution. What's the value of my... Well, first of all, do I have a max or a min? Yeah, this is a minimum. What is my minimum value here? Thank you, 1/2, because it's the y value. Where does it occur? It occurs at x equals 3/2. My brothers, let's be honest. Did I finally make this make sense to you guys? Because you've been seeing this for many years. Did it make sense today?
Yes.
You got any questions for me, my brothers? Have a great day. May God bless you all. I hope you learned a lot. Thank you.